Hello, students. Welcome back uh, in today's session. I hope my voice is clear to all. Am I audible? So let's just dive into our session. In today's session, we will be covering relation and function, some theory part. Mainly NCERT section 2.1, the introduction part, and 2.2. Okay. A small disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the part of the content may have been generated using generative AI, which is an experimental. Thank you. So, in today's session, we are mostly covering about a small introduction related to relations. Okay. And then the main subtopic of this chapter, Cartesian products of sets. And then we will be seeing some related example to the theory. Okay. Now, a small introduction. So, in mathematics, everything is about finding some pattern. Clear? A recognizable link between quantities that change. In our daily life, we came across many patterns that characterize relations such as brother and sister, father and son, teacher and student, a daughter and mother, etc. Okay. So, in a practical daily life, we have relationship like this. But how we are going to see pattern in mathematics? So, the role, the important role is played by what? Relations in mathematics. So, in mathematics, we come across many relations such as number m is less than number n. Any line is parallel to some another line m or perpendicular to it. Set A is a subset of B is also a relation in context of subsets, or you can also have a superset type of relationship between. Okay. So, in all these, what we noticed is that a relation involves pairing, pair of objects in certain order, in certain manner. In this, we will going to learn how to link. So, simply, what we are going to learn is how to link pairs of objects from two sets. Then introduce that as a relations between the two objects in a pair. Finally, we will learn about special type of relations which will qualify to be functions. And functions are very, very important in mathematics. Very important. So, in calculus, you always have to deal with functions. In trigonometry itself a function. Clear? So, this function is very important. So, please pay full attention to this topic, relations and functions, mainly functions. So, the concept of function is very important in mathematics since it captures the idea of a mathematically precise correspondence between one quantity to the another. Clear? Now, starting with Cartesian products. So, starting with an example, suppose A is a set of two colors and B is a set of three objects. That is, I am having my A set in roster form as red, comma blue. Any two colors. B with three objects naming B, C, S. Clear? Now, these BCS represents a particular type of what? Bag, coat and shirt. Now, actual question is how many pairs of colored objects can be made from these two sets? Let's see. So, we can see that there will be 6 distinct pairs as given below. What pairs? You can pair red with B, red with C, red with S, meaning shirt, blue B, blue C and blue S. Clear? So we are having 6 distinct pairs. Clear? So we got 6 distinct pairs simply. Now, the formal definition, what it says is that if you are having two non-empty sets P and Q, the Cartesian product P cross Q, denoted by this P cross Q or P times Q, is your set. What this represents is simply your set. Set of all ordered pairs of elements from P and Q. So mathematically, what we are trying to say is simply this P cross Q is your set. Set, what type of set? Collection of all pairs P comma Q such that P belongs to P set and Q belongs to Q set. Clear? So if either the P set or the Q set is null set, meaning empty, then the Cartesian product of the two sets will also be empty set, meaning P cross Q is empty. Clear? So let's see an example. So simply you are having a set A with these three elements DL, MP, KA, where DL represents your Delhi state, MP represents your Madhya Pradesh and KA represents your Karnataka state. And you are having another set B with three elements, so 01, 02, 03. So these just representing codes for the license plates of a vehicle issued by DL, MP or Karnataka. Clear? Now, if the three states Delhi, Madhya Pradesh and Karnataka were making codes for the license plates of vehicle with the restriction that the code begins with an element from set A, where which are the pairs available from these sets and how many such pairs will be there. So simple example. So solution. So very simple. So pairs are simply according to the example. So first you must have your state, so DL, then your code, so DL01, DL02, DL03. Now same goes for MP, MP01, MP02, MP03 and same goes for Karnataka, KA01, KA02, KA03. So the product of set A and set B is simply given by A cross B, which is equals to the set, the collection of pairs such that first element belongs to set A and second element belongs to set B. So you are getting how many pairs? Simply 9 ordered pairs. Clear? As you can see. So it can easily be seen that there will be 9 such pairs in the Cartesian product. Since there are 3 elements in each of the sets A and B, this gives us 9 possible codes. Also note that the order in which these elements are paired is crucial. Clear? So order is very important in Cartesian products. Always remember that. We are saying ordered pairs, not just pairs. Yes? So you can have in general idea about what if you have some m elements in set A and n elements in set B. Then the number of ordered pairs in the Cartesian product going to be simply m times n. Simple. Why? Because you have to choose or you have to pair for each element in set A to the each element to set B. Clear? So now, for example, the code, this pair DL, 01 will not be the same as the code 01, DL. As we have already said, what? That in pair, the order is very, very important, very crucial. If you change the order, you change the pair. It is not like the same as in sets. In set, if you change the order, it doesn't affect anything. But in ordered pair, it does affect the things. Clear? Okay. And if you try to observe from the set builder form of A cross B, your first element must be from where? A, and second element must belongs to what set? B. But this, if you try to see this, is this pair going to in the set A cross B Cartesian product? Is this belongs to the set A cross B? No. Why? Because the first element must belongs to the set A, but we do not have 01 in set A. So this pair is not going to be in A cross B Cartesian product. Also observe this. Now as a final illustration, simple, consider the two sets A having 2 elements A1, A2, B with 4 elements B1, B2, B3, B4. So just a simple question. How many pairs, ordered pairs will be in A cross B? How many? Yes, simple, 8 pairs. So what pairs? Simply, so just how we are going to construct our 8 pairs? Simple, your first in pair, the first element must belongs to set A and second element must belongs to set B. So A1, B1. Now A1 can be paired with B2. Now A1 can be paired with B3. A1 can be paired with B4. Now same goes for A2. A2, B1, A2, B2, A2, B3, A2, B4. Clear? So the 8 ordered pairs. We got 8 ordered pairs simply. Clear? And also observe this, that the pair A1, B2 is not same as saying B2, A1. And also this pair does not belongs to the Cartesian product of A cross B. Okay. Now some remarks. So first, 2 ordered pairs are equal if corresponding first element are equal and second elements are also equal. So when do we say that the given 2 ordered pairs are same? When the first element of the given ordered pair is same as the first element of the other given ordered pair. Also, the second elements be same as the second element of the other ordered pair. Okay. Now, second, if you are having p number of elements in set A and q number of elements in set B, then the total number of ordered pairs you will get in the Cartesian product A cross B is simply p times q. Clear? Third says, if A and B are two non-empty sets and either A or B is your infinite set, then A cross B will also be your infinite set. Okay. Now, fourth, what about if you are having this A cross A cross A? So this represents what? 3 tuple. So ordered triplet meaning. So here we are having how many elements? 3 elements. So we are using triplet term. Previously, how many elements we have got in our pair? Simply 2 elements. So we used pair. Clear? So by definition, A belongs to set A, B also belongs to this set A, and C also belongs to this set. Clear? So A, B, C is your simply ordered triplet. So same goes for this. If you change the order, you change the pair. Clear? Now, another example. So related to ordered pair and remarks we have seen. So you are given with that this ordered pair is same as this ordered pair. Find out your value of x and y. Very simple, very easy. So solution. So if you recall the remark, so what it says is if you are having 2 ordered pairs and both are equal. So when do we say that the given 2 ordered pairs are equal? When the first pair, and in first pair the first element must be same as the first element in the second pair, which is 3. So x plus 1 must be same as 3. Now the second element from the first pair must be same as the second element from the second pair. So you are getting y minus 2 is equals to 1. So now you are having 2 equations which can be easily solved. So you will get x as 2 and y as 3 in order to make both the ordered pairs same. Clear? So I hope the solution is clear to all. Moving to next. This question. So simply this just try to carefully observe what we can conclude from this example, because this example illustrates something. So focusing on this example, so P set is given to you with 3 elements A, B, C. Q set, singleton set, in which we are having just a single element R. Now you have to find out P cross Q set and Q cross P set. And observe, are we having both these sets equal or not? Simple question. So solution. So recall the definition of Cartesian product. What it says? Simply, in order to write P cross Q, you have to collect pairs in which first element must belongs to the set P and second element must belongs to the set Q. So in set P you are having 3 elements, in set Q you are having just 1 element. So in total how many pairs you will get is simply 3. Yes, 3 times 1 3. Now what will be our pairs? Simply, so A can be paired with R, B can be paired with R, C can be paired with R. So A comma R, B comma R, C comma R. Clear? Now second says that you have to find out Cartesian product Q cross P. By definition, you have to collect pairs. What type of pairs? The pairs in which the first element must belongs to the set Q and second element must belongs to the set P. Yes? So R going to be pair with A, R with B and R with C. You have only these 3 pairs in this set Q cross P. Now, what about the equality in between these two Cartesian products? Are we having same? No. Why? Because in order to get the same set, what we must satisfy that every element from this set must be in this set. But what we are having is simply this pair is not equals to this, because both are ordered pairs, and in ordered pairs if you change the order, pair is also changed. They are not the same. Or if you are having 2 pairs, if they are same, they are going to be same when the first element is same as the first element and second element is same as the second element. Here we are having the opposite. A is not same as R and R is not same as A. So not equal. Clear? So in general, what you can say is, what you can comment, what you can conclude is simply that P cross Q is not same as Q cross P. In general, the Cartesian product is not commutative. Clear? Another example. In this set, A, we are having 3 elements, 1, 2, 3. In set B, we are having 2 elements, 3, 4, and in C set, we are having 3 elements, 4, 5, 6. So you have to find out A cross B intersection C. And second, A cross intersection A cross C. Then very simple. So solution, very simple. So first you have to solve for this bracket B intersection C. So what this set represents, you have to collect all those elements which belongs to both set B as well as in C. So you are having only one element which belongs to the both sets B and C. So just 4. So singleton set. This intersection will be a singleton set. Now you can easily do or find out this Cartesian product A cross B intersection C. So in set A you are having 3 elements. In B intersection C you are only having just 1 element. So in total in this Cartesian product you are going to have 3 pairs. What pairs? So first in pair the first element must belongs to set A and second pair must belongs to this intersection B intersection C. So you are having your pairs as 1, 4, 2, 4 and 3, 4. Clear? Now second, in order to solve for this, first of all solve for these brackets A cross B and A cross C. So in order to find A cross C, very simple, by definition you have to collect your pairs in which the first position is going to be filled by the elements in set A and second in set B. So you are having 3 numbers, 3 elements in set A and 2 elements in set B. In total you will get how many pairs? Simply 3 times 2, 6 pairs in your Cartesian product A cross B. Pairs are 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. Now the same goes for A cross C. How many elements you will have? Simply very simple. 3 elements in set A, 3 elements in set C. So 3 times 3, 9. So you will have 9 pairs in A cross C. Pairs are 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6. Now, what you are observing is simply that both the sets, if you see now, what you have to answer is simply intersection in between A cross B and A cross C. So intersection meaning you have to pick common pairs from both the sets A cross B and A cross C. So common pairs are what? 1, 4 and 2, 4 as you can see, and 3, 4. Clear? So you are having just 3 elements in the intersection. Okay. Now one thing that you have to observe is that both these sets, what sets? A cross B intersection C and A cross B intersection A cross C are the same. Yes, both sets are the same. Clear? Now this example, set A with 3 elements 1, 2, 3, set B with 2 elements 3, 4 and set C with 3 elements 4, 5, 6. Now here you have to find out A cross B union C and A cross B union A cross C. Very simple. Solution. The approach remains the same. Solve for B union C. So how you are getting this B union C? Simply just collect all the elements from the set B as well as from C and write the repeated elements only one time. So 3, 4, 3, 4, 4 already been collected. So now collect just 5, 6, 5, 6. So in B union C, you will have 4 elements 3, 4, 5, 6. Now you can this is very easy to find out A cross B union C. You know your B union C set. So A cross B union C. How many pairs you will have? Simply in set A you are having 3 elements. In B union C you are having 4 elements. So total number of pairs simply 3 times 4, 12. So these 12 pairs are 1, 3, 1, 4, 1, 5, 1, 6, 2, 3, 2, 4, 2, 5, 2, 6, 3, 3, 3, 4, 3, 5, 3, 6. Now for A cross B union A cross C, quite simple. We have already seen what is our A cross B and A cross C. Now we are just collecting all elements from both the sets as we have to construct this union set. So the set is 1, 3 pair 1, 4, 1, 5, 1, 6, 2, 3, 2, 4, 2, 5, 2, 6 and 3, 3, 3, 4, 3, 5, 3, 6. Just observe carefully that both sets, as you can see, having exactly the same elements. Yes, exactly the same elements. So both sets are the same. Okay. Yes, they are. I hope this example is clear to all. Moving to next. Now, an interesting example. Here, if P set is your set with 2 elements 1, 2, then find out P cross P. Very simple. We have seen a related remark. So solution. So quite simple. If you recall the remark, what it said was simply that you have to collect triplets, ordered triplets, in which first position, second position and third position all coming from what set? P set, in this case P set. So 1, 1, 1. Now 1, 1, 2, 1, 2, 1, 1, 2, 2, 2, 1, 1, 2, 1, 2, 2, 2, 1 and 2, 2, 2. Simply, how many elements we are getting? So for this we are having 2 elements, for this 2, for this also 2. So 2 times 2 times 2, in total 8 pairs we are going to have, and you can easily verify that thing, that we are indeed getting how many pairs? 8 pairs. Yes, I hope this example also clear to you. This is same as saying you are tossing your 3 coins simultaneously. Now, another example. If you are having your set of reals, so this R represents your what? Real number set. And just describe what is your R cross R and this R cross R cross R. Very simple. It's a solution. So R cross R is simply in set builder form. So what you are doing is simply collecting your ordered pairs x comma y. You are collecting your ordered pairs x comma y such that this first elements belongs to this set R and second also belongs to this second set R. In this case, these two sets are the same, so x y both belongs to the set of reals. Clear? And this is nothing but your two-dimensional coordinate plane. Clear? Now for R cross R cross R, in this you are collecting your ordered triplets. Ordered triplets meaning you are having 3 position, first, second, third, x, y, z. And all this first belongs to this set, second belongs to this set, and third belongs to this set. Meaning in this case you are having all these sets same, so x, y, z all belongs to the set of reals. And this particularly represents your 3-dimensional coordinate space. Clear? So thank you